So we spent the past couple days reviewing the exponent rules. So with that, I got a quick little problem for you. If I have a to the k power times a to the k power, and that's equal to a, what is the value of k? Well, from our exponent rules, we've seen that a to the something times a to the something. What are we supposed to do with those exponents? We should add them. So k plus k is a to the 2k equals a. A to the what? What's the exponent here? A to the, if there's nothing there, there's a 1 there. So if a to this is equal to a to that, it should make sense that 2k, this equals that. Thus, what is k? K is 1/2. So now we know what k is 1/2. That should bring up some interesting questions. First of all, we've talked about positive exponents. We've talked about 0 as an exponent. We've talked about negative exponents. What we haven't done are fractional exponents. And with here, k is equal to 1/2, that brings up an interesting question. What times itself will give us just the base by itself? So for example, if I had 5 times 5 equals 5. Now we know that's not true, right? 5 times 5 is 25, but we could do some sort of notation, some sort of other symbol, where if we did 5 with some symbol times 5 with the same symbol is equal to 5. Some of you may have come up with it. The square root of 5 times the square root of 5 is indeed 5. Right? So think about this. That means that 5 times 5 is equal to 5. That means that k, or the exponent here, would have to be 1/2. 5 to the 1/2 times 5 to the 1/2. Add the exponents, you get 5 to the first power. So extend that even further. Then that means that the square root of a equals a to the 1/2. Right? If we could do root 5 times root 5 and get 5, and we do 5 to the 1/2 times 5 to the 1/2 is equal to 5, then that means that these two things are equal. And that's what today's lesson is all about, is fractional exponents. If we have n, the nth root of a, that is equal to a to the 1 over n. All right, that's the big idea today. That's what we're talking about here. Now, this n inside here, this has got to think, this is called the index. It's got a fancy name. It's called the index. And with that being the index, this form here, the nth root of a, this is radical form. And this is exponent form. Exponent form. All right, so check this out. Here's a little trick question. The square root. We've talked about the square root of a before, and we're saying that's a to the 1/2. What is the index of the square root? Well, n down here is 2. When there's a square root, there's actually a 2 there. Even though you don't see it, there's actually a 2 there. Anyway, so we're going to do some problems with rational exponents. Rational exponents. And what's that talking about? Well, here's the thing. A to the m divided by n. Let's break it down. Let's break it down to that old rule. A to the m quantity to the n. What do you do with those exponents here? You multiply them. A to the mn. Right? So what that means here is we can actually break this apart. We can make this a to the 1 divided by n quantity to the m power. See how using this rule here, it would multiply up. Hold on.
Maria Villera, please come to the attendance office. Maria Villera, please come to the attendance office.
So, got to hear a little bit about Maria there, I guess. A to the 1n times m. You can see how it's split apart there. So, what does that mean? That means this is the nth root of a. That's this inside part here. And that whole thing is raised to the m power. That's one way to write it. Or we could write it as this. A a to the m divided by n can also be written as a to the m to the 1 divided by n, right? That's still, if we multiply the exponents, we get m divided by n. So that would be a to the m, but that whole thing is the nth root. Remember, the denominator is always going to be the index for these fractional exponents. Denominator is going to be the index. So there's two ways to write this. I'm going to be honest with you. Excuse me. While the book kind of likes this one, I'm kind of partial to this guy here. I'm partial to this one. And we'll find out more about why I like this one a little bit better tomorrow. But for right now, yeah, we're just down with that. All right, let's do a couple of examples here. Example 1. 16 to the 5 halves power. 16 to the 5 halves power. Now, let's talk about what that means. That means the square root, right? The square, excuse me, I'm going to rewrite this a little bit differently. The square root of 16 to the 5th power, or the square root of 16, and that is to the 5th power. Now, we can take this a little bit further. What is the square root of 16? Well, the square root of 16 is 4. So we have 4 to the 5th power. And that is 1024. All right. Now, from here, it's not so obvious to see. So this is one example where it's like this. Today, I should amend that. Today, this one's going to be helpful, but tomorrow we'll like this one a little bit better. We'll talk more about that tomorrow. Anyways, number 2. 49 to the 3 halves power. 49 to the 3 halves power would be, again, let's write this as exponents. This would be 49 to the 1/2 power. And then that would be to the 3rd power. See how 3 halves is the same thing as 1/2 times 3? Well, 49 to the 1/2 power, that's the square root of 49 cubed. The square root of 49 is 7 cubed, which 7 to the 3rd power is, go ahead and use your calculator, that's right, it's 343. Let's try one more. 3. Let's go with 2 to the 3/5 power. 2 to the 3/5 power. What does that mean? Well, that means 2 to the 1/5 to the 3rd power. Or 2 to the 1/5 is the 5th root of 2 raised to the 3rd power. I'm totally fine with that. Or I would also accept the 5th root of 8. All right, so rational exponents, guys, here's the bottom line. The denominator is the index. That's the biggest thing to get out of there. All right, now, with that comes more on rational roots. Let's go to a new page here. Rational roots. So, talking about our index, n of a, the nth root of a. Now, if n is odd, then check this out. There is one real nth root. Let me show you an example of that. Let's talk about the square root, the cube root. We want n to be odd. The cube root of -8. What number times itself 3 times is -8? Well, -2 times -2 is -4 times, positive 4 times -2 is -8. So the cube root of -8 is -2. That's it. What about positive 2? Does positive 2, if I cube that, will I get -8? No, positive 2. 2 times 2 is 4 times 2 is positive 8. So there's only one answer here. Oh boy, here we go.
Haley Boyd, please report to Student Services.
Here comes Haley now.
Haley Boyd, please report to Student Services.
Now, what if n is even? What if n is even? Well, here's where it gets tricky. There's 3 scenarios here. 1, if n is even and a is positive, that means there's going to be 2 real roots. 2 real roots. Excuse me. If a is 0, then there's 1 real root. And if a is negative, what do you think that means? No real roots. Check it, let's do an example here. What if we had the 4th root of 16? What number times itself 4 times is 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 does work, but what about negative 2? What's negative 2 times negative 2? Positive 4 times negative 2 is negative 8, times negative 2 is negative 16. Oh my goodness.
Boyd, please report.
So our answer here is going to be plus or minus 2. Plus or minus 2. There's 2 real roots here. Think about square root. When we did the square root of 16, our answer was always plus or minus 4 when we were solving. Think of when we're talking about nth roots, we're talking about solving here. So what is the 4th root of 0? What times itself 4 times is 0? Well, the only thing that does that is 0. And then what is the 4th root of negative 16? What times itself 4 times will give you a negative? Well, again, since it's an even root, nothing times itself 4 times or an even amount of time will give you a negative number. Thus, this is no real solution. Now, some of you might be thinking, what is the 4th root of negative? We don't want to even deal with that. That's a mess you don't want to take part in. So, if it's even, or excuse me, if it's odd, if n, the index is odd, there's 1 answer. If it's even, watch out. There's a couple things that can happen here. So let's do a couple examples. First of all, let's do find the nth root. Find the nth root of a. Let's do an example here. N equals 5, a equals negative 32. Well, again, this all goes back to the nth root of a. So what we're saying here is, the 5th root of negative 32. What times itself 5 times is negative 32? That's right, it's negative 2. All right. How about another one? 2, n is 4, and a is 625. So what are we doing here? We're saying the 4th root of 625. What times itself 4 times is 625? Well, since it's an even root and we got a positive number, it's going to be plus or minus. The square root of 625 is, oops, excuse me, not 25. It is 5. 5 to the 4th power is 625. So, but it's plus or minus. One more example, and then I'm done with you. N is 6. A is negative 64. Talk about that one. That says the nth root, or the 6th root of negative 64. N is even, and a is negative. Can we take something times itself 6 times to get a negative? No, we cannot. So this is no solution. All right, so in class tomorrow, we're going to be talking about how to solve. Algebra is all about the never-ending search for x. That's what a lot of this is going to start coming down to, is how to solve for x. So that's what we're going to be talking about. To show me that you read this or you listened to this video, On Edmodo, there will be a quiz. Name one of the students that got paged.